Hello and welcome to RTOS Logic videos. Let's discuss today about a very interesting topic of role of sensors in embedded systems. What are sensors and why are sensors or sensing so important in embedded systems world? Sensors are essential components or devices of embedded systems which enables an embedded system to interact with the physical world, which enables embedded system to interact with our environment. In simple words, sensor is something which converts a physical phenomena into electrical signals, and embedded systems can understand these electrical signals and process them as required. Just imagine sensors are like sensing organs of our body. In fact, the entire embedded system is like our human body. Let me give an example. Our tongue is nothing but a sensor. Whatever food goes on our tongue, its taste is sensed or detected by the tongue, and signal is sent to our brain. And then the brain decides, the brain reacts. Okay, the food is sweet or spicy or sour. And we have been taught in our schools that our skin is the largest sensing organ in our body. Let us say if someone pinches you on your skin sharply, skin senses that and sends a signal to your brain, and then brain takes action and sends back a signal to your hand, and your hand rubs it off, right? Or brain sends a signal to your vocal cords or mouth, and mouth says ouch. So this exactly can be related to an embedded system, and only difference is a human body is programmed by God, whereas embedded system is programmed by humans. Okay, coming back to our topic, let me give you a very simple and basic example about a sensor. Let's say I have an embedded system which takes an input from a temperature sensor. This temperature sensor is capable of sensing the surrounding temperature where this embedded system is installed or placed. Okay, now the surrounding temperature sensed by this sensor is read by the processor or CPU, which is the core or brain of an embedded system. Now, based on the application of this embedded system or use of this embedded system, this sensed temperature will be utilized. For example, if my embedded system's purpose is to just display the surrounding temperature, then the processor is programmed in such a way that the temperature is displayed on an output device, which may be an LCD display or LED display or anything. Or consider another simple use case where this embedded system is installed in an industrial equipment. Here, the temperature sensor senses the temperature of the equipment, and CPU reads this sensed temperature from the sensor, and the CPU is programmed in such a way that if this input temperature of the equipment is greater than 50 degrees Celsius, then the CPU sends a signal to an alarm system, which is an output device here. And if the equipment temperature is reduced below 45, then the alarm is switched off. Okay, we talked about only temperature sensors here. There are many more different types of sensors, and each type of sensor serves a specific purpose, and it is used in different applications. Let's discuss about few of them here, like pressure sensors. Pressure sensor measures or senses a pressure or a force exerted by a fluid on its surface. Here, fluid can be either liquid like water, fuel, or gas like air, oxygen, nitrogen, anything. With the help of pressure sensors, an embedded system can monitor and control pressure in hydraulic and pneumatic systems in industrial automation. And embedded systems in medical equipments, pressure sensors are very crucial in blood pressure monitoring, respiratory equipment, and infusion pumps equipments. And embedded systems in aerospace, pressure sensors are used to measure altitude of an aircraft, cabin pressure control system of an aircraft, and fuel pressure monitoring, and lot more. And in consumer electronics, smartphones, wearables, and other portable devices use pressure sensors for altitude or depth measurements. Then another type of sensor, motion sensors. Motion sensor detects motion or movement in their surroundings. Again, lots of applications or uses of motion sensors exist, like security systems, smart lighting, consumer electronics, automotive, industrial automation, robotics, lot of applications for motion sensors. Take example of smart lighting. Every one of us would have experienced in our offices, smart homes, shopping malls, like motion sensors control lighting systems by turning lights on or off based on detected movement, which enhances the electricity or energy efficiency. Like if there is no one present in the room lights are turned off automatically. Okay, then proximity sensors are devices that detect the presence or absence of an object or an obstacle within a certain range without the physical contact. They play a vital role in various industries and applications, providing input for automation, safety, and user interfaces. Take example of embedded systems in automotives. Proximity sensors are used in automotives, in cars, in parking assistance systems, obstacle detection, and collision avoidance. Then light sensors, also known as photodetectors or photodiodes. These are the sensors or devices that detect the presence of light, intensity of light, or wavelength of light. A very simple and common example every one of us know. In almost every smartphones we are using today has automatic brightness adjustment of the screen. As soon as you go out in a sunny space, the brightness is automatically increased. And when you enter in a shade or a shadow, the brightness is decreased. How is that possible? This is possible with the help of light sensors in embedded systems in our smartphones. Then one more type of sensors, last one I would like to cover here, is sound sensors. Sound sensors, also known as acoustic sensors or simply microphones, are devices which are designed to detect sound waves and convert these sound waves into electrical signals. There are many examples like voice recognition systems, monitoring noise levels in urban areas or public places. Sound sensors may also be used for security purposes like detecting glass breaking or unusual noises in some places. Now, importantly, how these sensors are integrated with the embedded systems. So, as I mentioned earlier, any sensor senses or detects the environmental or surrounding data, which is physical data like light or temperature or force or motion, etc. This is physics, like it's a physical data. And then sensor generates electrical signals or analog signals, which may be voltage, current, resistance, or any other analog representation of the data. Now, these analog or electrical signals usually need some kind of signal conditioning in order to meet the requirements of the embedded system. For example, signal conditioning may be like amplification of that signals or filtering of the signals or any other adjustments to ensure the signal is within the desired range and useful. Then this analog data is then converted to digital data with the help of ADCs, that is analog to digital converters. This digital data is then sent to CPU or microcontrollers or microprocessors, because microcontrollers or microprocessors understands or decodes the digital data only, and the communication between the ADCs and CPUs or microprocessors may occur over communication protocols or interfaces like I2C, SPI, or UART, depending on the sensor and the embedded systems architecture. So, this digital data is sent from ADCs to the microprocessors or microcontrollers through these interfaces or these communication protocols. Hope you like this video. Please subscribe and comment if it was helpful. Thank you.